Question 20. Find the quadratic equation whose roots are 2 and 3 whole number 1 over 2. Here we are asked to find the quadratic equation whose root are this, that is to construct quadratic equation with this given roots. The roots we have are 2 and minus 3 whole number 1 over 2. So let's call this alpha, and let's call the second root beta minus 3 whole number 1 over 2, which will change that to improper fraction. It's going to give us minus 7 over 2. 2 times 3, 6, 6 plus 1, 7, and the negative sign here. Now, to construct a quadratic with given root, we can make use of x squared minus the sum of the root, sum of roots plus product of roots equals 0. So, and we said let the first root be alpha and let the second root be beta. That means this can also be x squared minus alpha plus beta x plus alpha beta equals 0. So now we can have this as x squared minus, by the time we sum the root, we are going to have 2 plus minus 7 over 2 plus 2 times minus 7 over 3. We have this. So here we have x squared minus, by the time we sum these two together, this is going to give us 2, 1 minus, it's going to give us, here is going to give us 2, this is 2, this here means 2 over 1. Then we are going to have here to be 4 minus, here is going to give us 7, because plus times minus give us minus, all over x, plus here 2 will cancel 2, we are left with minus 7 equals 0. Here we are going to have x squared minus 4 minus 7 give us minus 3 over 2 x plus times minus give us minus 7 equals 0. Now if we check here, we have a fraction here. What do we do so that we can eliminate the fraction? We say multiply through by 2. We have 2 x squared minus 2 bracket minus 3 over 2 x minus 2 bracket 7 equals 0. You are going to have 2x squared, 2 will cancel out, minus times minus, you are going to have plus 3x minus 2 times 7, 14 equals 0. So we have construct a quadratic equation with this root. So now, which of these options we have? The quadratic equation is 2x squared plus 3x minus 14 equals 0. So which of these options fits in into this? This is option D. Ṣó le, kò le.